When we think about how AI learns, what comes to mind? Probably some sci-fi movie stuff, right? A computer that thinks and reasons. Well, the reality is, it's a lot less like a superbrain and a lot more about a really, really simple idea repeated an insane number of times. So let's break down what's actually going on under the hood.
Yeah, just forget everything you know about learning from books. An AI has no clue what a cat is. It doesn't read a definition that says a small, domesticated, carnivorous mammal. Instead, it just stares at millions and millions of pictures of cats. And that's the huge difference, right? It's not about understanding. It's about finding patterns on a scale that's just mind-boggling. And this slide, it just lays it all out perfectly. We humans, we build these rich, abstract ideas in our heads. But in AI? Nope. Think of it more like a bloodhound, but for patterns. It just sniffs its way through these gigantic mountains of data, looking for what's common, what repeats. It's not thinking, it's just doing brute force repetition until a pattern emerges. Okay, so pattern finding. That sounds cool, but what does it mean? How does it actually work? Because the results, they can feel like pure magic, but the engine driving it all, it's way, way simpler than you'd think. Seriously, this is it. This is the secret sauce. The entire mind-bendingly complex world of AI training boils down to this one super simple three-step loop. You guess, you check, you adjust. That's the whole game. The only trick is you do it over and over and over again. We're talking millions, sometimes billions of times.
All right, to really get a handle on this, let's use a great analogy. Let's talk about learning to play darts. Picture it. You're in a pub. You've never thrown a dart in your life. What's the first thing you do? First, you just throw the dart, right? That's your guess. Then you look up and see where it landed, probably way off the mark. That's your check. And then for your next throw, you think, okay, I need to aim a little higher and to the left. That's the adjust. And believe it or not, that is exactly the process a neural network goes through. So let's really zoom in on that first step, the first throw. What does it look like when an AI makes its first totally random guess? Now, in the world of AI, this has a fancy name. It's called a forward pass. But don't let the jargon intimidate you. All it means is the data, say an image, gets pushed forward through all the AI's internal circuitry, from the input all the way to the output, where it spits out a prediction. It's just the throw. And this is maybe the most important thing to grasp. The AI doesn't see a picture of a cat or a t-shirt. Not at all. It sees this, a big grid of numbers. Each number is just a value of a single pixel. This spreadsheet, this is the AI's entire universe. It knows nothing else. So what does it do with this grid of numbers? Well, it feeds them into its network. And you can think of the network as being full of thousands, even millions, of little digital knobs, or weights. It runs the numbers through all these knobs, does a ton of math, and out comes a set of scores. They're called logits for every possible category. The highest score, that's its guess. Simple as that. Okay, so the dart has been thrown. The guess has been made, but was it any good? How does the AI even know? Well, this is where we get to the second part of our loop, the check. The first thing it does is calculate something called loss. Again, sounds technical, but it's just a number, a score. It's the ouch score. A really high loss number means, wow, you missed by a mile. A low loss number means, hey, you're pretty close. The whole point of AI training, the entire goal, is to get that loss number as close to zero as machinely possible. But just knowing you missed isn't very helpful, is it? You gotta know why you missed. And this is where the real genius comes in. It's a process called backpropagation. And what it does is it works backwards from that ouch score, from the loss, and does some clever math to figure out which of those thousands of little internal knobs were most responsible for the mistake. It's like assigning blame for the error. So why does this matter so much? Because without backpropagation, the AI is just flying blind. It's the difference between a dart coach just yelling, "You missed," versus one who says, "You missed because you flicked your wrist at the last second." One is useless feedback, the other is actionable. Backpropagation gives it that actionable feedback, and that's the only reason it can improve at all. Which brings us to the grand finale of the loop. We've made our guess, we've checked how we did, we've figured out why we were wrong. Now it's time to actually adjust our aim. And this part is pretty straightforwardly named. It's called updating the weights. Using that specific feedback it got from backpropagation, the AI goes back to all those little internal knobs, the weights, and gives each one a tiny, tiny nudge, just a little twist in the right direction to make the next guess just a little bit better.
Now, how big is that nudge? That's controlled by a setting called the learning rate, and getting this right is crucial. If your learning rate is too high, it's like yanking your arm wildly to correct your dart throw. You'll just overshoot and miss on the other side. If it's too low, you're making such tiny adjustments that it'll take you forever to get any better. It's all about finding that sweet spot.
And there you have it. That's the whole cycle. So now let's pull back and look at the big picture. How does this simple, almost dumb loop of guess, check, and adjust add up to something that looks like intelligence?
This chart just puts it all together perfectly. You have the forward pass, that's your throw. You calculate the loss, that's measuring how badly you missed. You use backpropagation, that's figuring out why you missed. And then you update the weights, that's adjusting your aim for the next shot. That's the whole shebang, right there.
But here's the kicker. The real magic, if you want to call it that, isn't in the loop itself. It's the scale. This isn't happening 10 times or 100 times. This loop repeats at a blinding speed, millions, sometimes billions of times on an ocean of data. Each time it makes a teeny tiny microscopic adjustment, but all those tiny adjustments, they add up.
So, next time you see an AI do something that just blows your mind, remember what's happening underneath. It's not thinking in the human sense, it's not conscious. It's the final result of a methodical, relentless process of trial and error, of tiny, guided adjustments, all happening at a speed and scale that is, frankly, almost impossible for us to wrap our heads around.
And this whole process leaves us with one really important, kind of scary final thought. If an AI only learns from the examples we give it, if it's just a pattern-finding machine, then what happens when the patterns in our data are, well, biased? It means the quality, the fairness, the hidden biases in the data we create, that becomes everything. Something to think about. Thanks for joining.